Hello, VueConf. Thank you guys so much for having me today. I am very excited to talk to you about one of my favorite topics in the context of my favorite framework. So let's dive in and talk about performance-minded development with Nuxt 3. My name is Valerie England, as you just heard, and I'm a development manager at Continued. Continued provides high-quality, affordable, online continuing education for a whole bunch of different professions across a wide array of industries. And we're a fully remote company and have been since our inception in 1999, actually. At Continued, I serve as a technical leader, primarily focused on the front end of our product. And I lead a team of awesome developers, two of whom are in the audience, building applications in Nuxt, Vue, GraphQL, and Laravel. I've been working in development since about 2009, serving in a management capacity for the past decade or so, but I still really enjoy rolling up my sleeves and coding whenever I have the chance. You can find me at GitHub or X at Valernix, or feel free to drop me a message through email or LinkedIn, or come up and have a chat. And if you're interested, you can pick up the slides for this talk at the QR code there, and if it's too small to see, it's bit.ly/Nuxt3PERF. And now that you know a bit about me, let's talk about performance. I'd like to kick things off with a bit of a story here. So let's say you were diligently working on a large-scale Nuxt application, and you've been hard at work for years. You migrated successfully from Nuxt 2 to Bridge, and finally to Nuxt 3. From a statically generated application to a server-side rendered one. And you're loving all of the new tools and paradigms that Vue 3 and Nuxt 3 bring to the table. Then, as you finish all your key features and you begin to think about your impending launch, you run some performance audits with Google Lighthouse, and 32, 33. And seriously, a 4? So this is the situation I was in last autumn with my team. With over 2 years of rapid development, we'd accomplished so much. But in the process, we fell into a few pitfalls that were hampering our app's performance. So I want to spend the next 30 minutes, give or take, and take you on a journey of how we went from here to here. And I like to think of it as summiting a mountain, and Nuxt likes mountains. So I'm going to use that as a metaphor as we go. And along the way, my goal is to provide you with a performance-focused toolkit you can apply towards current work or maybe a future app on Nuxt 3. So let's get started. All right, so as we prepare to climb this mountain, we need to start by establishing our base camp, a foundational understanding of web performance and why it matters. So reviewing Google's core web vitals is a good place to start here. And I put a link down below, which you can pick up for even more details. From here, we can get up to speed with our various measurement tools and learn when, where, and how to capture metrics. Data from lab simulations is not going to match up one-to-one with real user data from the field, but each of these plays a part in helping understand your app's overall performance. And next, you can establish your benchmarks using industry best practices, Google's recommendations, or even competitive product comparisons if that applies for your case. Last but not least, make a plan to aspire toward. What areas should we focus on for the largest performance gains? And don't forget, ultimately, why we're embarking on this journey in the first place. What's going to have the greatest impact to your end users and create the best experience for them? So our preparations have been made, and we're about to set off on this climb. As we embark, I'd like you all to try to keep these 4 things in mind. Be prepared for anything. Do look twice. Don't leave things to chance, and exercise control. So these really underscore the key learnings that I hope you take with you from this talk and bring with you into your next Nuxt application. And I'd also like to call attention to this little sentence here. The client enjoys browsing cookies in the window display. So just tuck that away for now, and we'll come back to it a bit later. Now it's time to dig into the technical side, and I'll cover some key patterns to practice, as well as some pitfalls to avoid. And our first pitfall is bloated builds. We need to ensure that we pack lightly, taking only what we need, where we need it. Nuxt is really dev-friendly, so it's really easy to get started with, but it can also be easy to fall into a little bit of a kitchen sink approach and end up with an application that's carrying along some extra bloat. So Nuxt Analyze is a really good starting point to get a true picture of your baggage or your production bundle size. You can alias this command and run it with your package manager of choice, for example, pnpm run analyze. And what Nuxt Analyze will do is it's going to assess your application's client and server bundles in production mode, and then output the results in this helpful visualization. And it's chock full of details. You can see things like the relative size of your dependencies against each other, the rendered and the gzip size of all your packages, as well as in some cases, which areas of your Nuxt app are importing it. So the first step here is prune unused packages and dependencies by uninstalling them, of course. But also identify if a particularly heavy package might have a lighter replacement that still provides you with all of the necessary functionality. If you do have to keep a heavy package, look if there's an opportunity to selectively import only the specific utilities that you need. And along these same lines, it's good to look for some tree shaking options to remove any features that you aren't actively using. There isn't a one-size-fits-all for tree shaking, as it's going to depend on what your package supports. But here's an example of how to set it up for Vuetify. Just remember to remove those wildcard imports so you don't carry all the components and directives with you anyway. Another useful tool for determining unused code is Chrome's coverage panel. So this is going to show you the percentage of unused CSS and JavaScript on the current page, but you likely need to work with it just a little bit with its instrumentation to get the most accurate results. But it's a helpful tool for comparing the before and after impact of your tree shaking efforts. And then for custom CSS, a final recommendation would be to investigate something like Purge CSS, which is going to do a terrific job of removing unused styles that you've written yourself from your pages and components. As we continue to take our first tentative steps up this mountain, there are some slippery slopes related to Nuxt itself that you should be aware of. So these features are fantastic, but they can be used in a non-optimal way and end up creating extra weight for your app. First up, we have Nuxt middleware. So middleware isn't global by default, but if you add the global suffix onto the file name, then it's going to be run on each and every route in your application. If you're doing something expensive in that middleware, like calling an API, then that can really add up. So whenever possible, you want to nix that global suffix and include your middleware only on the pages that really need to run it. And also consider if your middleware really needs to run on both the client and the server. To tailor where it runs, you can add the client or the server suffix accordingly. And next we have Nuxt plugins. So plugins and their registration are going to block your page's hydration. So while there are important use cases for them, make sure that your use case is informed and intentional. Plugins are going to load sequentially in alphabetical order by default, but you can change this and speed things up a little bit by adding parallel true in your plugin declaration, and then the order it loads in will be asynchronous. And as with middleware, you can also tailor where your plugins run using the client and server suffixes. When it comes to component imports, you want to steer clear of global registration where you can. So again, Nuxt doesn't do this by default, but if you place your components in a global folder, use the global file name suffix, or even set global true in your Nuxt config file, then your components will be accessible throughout your entire application. And as you might have noticed, we've got a bit of a trend here. Global items have the potential to really weigh us down. So instead, what you want to do is opt for dynamic imports and let Nuxt decide when to import your components. And then for components that aren't immediately visible on page load, you can prefix them with the lazy keyword and further optimize your app's initial bundle size. Finally, a quick note about Nitro plugins. So these are different from Nuxt plugins as they operate directly on the Nitro server, and they offer powerful capabilities to modify its functionality. However, you need to be a bit cautious here. So if you leverage your Nitro plugin to do something like modify the SSR response, as in my example, it can actually significantly slow down the delivery of that response as the server has to parse through your plugin logic in real time. So we've typically found a better approach to be modifying the files and their manifest during build time using Beat, and I'll share a bit more about how to do that in just a few minutes. So we've optimized the bundles that we could, and we revised our app to avoid those slippery slopes. Let's run a scan with performance insights. But wait a second, what is causing this massive idle time right in the middle of our page load? It pushed out the core web vitals to nearly 5 seconds. Our culprit here is an overzealous use of the client-only component. Now, this component is useful, and as the name implies, it defers any elements inside of it to render and execute solely on the client side instead of on the server. It's a really good tool for specific components which are not SSR friendly, particularly if they come from third-party packages or scripts, and you cannot add that compatibility easily yourself. However, if you wrap your entire Nuxt layout in the client-only component, for example, you're essentially telling Nuxt to render your layout and all of the pages that use it like an SPA, and forcing all of that JavaScript that your app needs to execute to run on the client. That large gap in our performance chart was the browser trying to parse all of the JavaScript necessary for our page to render. And while that was happening for several seconds, our users are just seeing a blank white screen. Far from an ideal user experience here. So use client only where it makes sense, and otherwise let Nuxt decide and execute as an SSR app and reap the performance benefits of that. If you do utilize client only, know that it is going to cause a rather awkward pop-in during hydration, which will likely cause a layout shift unless you take advantage of its fallback slot. So I do highly recommend leveraging this in combination with something like skeleton loaders to create a really seamless transition during hydration. And speaking of, performance is not only about actual load times, it's also about perceived load times. And this is where skeleton loaders come in and create a nice user experience for us. So well-crafted skeleton loaders enable you to avoid that cumulative layout shift during hydration or data loading. And as mentioned previously, you can use this technique with client-only's fallback slot, but you can also leverage it as a conditional keying off of Nuxt's SSR context, which I'll speak more about in a minute, or something like a data loading ref. And Vue Skeletor is a fantastic package for skeleton loaders, which is Vue 3 and Nuxt 3 compatible, and also SSR friendly. We need to be careful when we're working with client and server template conditionals to avoid DOM hydration mismatch warnings from Vue. So these mismatches can cause breaking downstream effects, such as a section of the DOM being rendered twice if Vue isn't able to synchronize your client and your server vnodes. So definitely don't ignore these. But to avoid them, you need to ensure that the client and the server both have the same type and the same number of nodes, and that their attributes, children, and their content are all in alignment as well. And in this first example here, it might seem like nothing's really amiss, but we actually have both a type and an attribute hydration mismatch that will occur here. So to fix these warnings, we could add the as prop to Skeletor, telling it to render that second node as a span. And we also need to move the classes that are common to both the server and the client to the wrapper div instead. I also want to note that it may make sense in certain situations to use vshow instead of vif, which will avoid these type of mismatch warnings entirely. It's situational, but it's worth noting as it can be an easier option to work with overall. So now we've removed client only from wrapping our Nuxt layout, and we added it only to the components that truly need it. We've made sure we have some skeleton loaders to create that nice end user experience, but suddenly we're receiving errors and our page is no longer rendering. What gives? Our third pitfall here is overlooking the lifecycle in the setup of our pages and components. Some items inside of script setup may also need to be deferred to the client, and we can use process.client or the newer import.meta.client as a conditional to help with this. Remember from earlier the client browsing cookies in the window display? So this sentence gives us some clues about some likely culprits which we might want to call inside of a process.client check, but it's certainly not an exhaustive list. The window and the document objects are straightforward enough. On the server, there is no browser window, so you have to defer these items to the client. Same goes for event listeners, such as those that are tracking a user's scroll position. And then similarly, the use of JavaScript's local storage API must run on the client because it's leveraging the local storage within the browser. Now we get a bit more into the it depends zone. So useCookie, which is a built-in Nuxt composable, is SSR friendly, but it might not work exactly as you expect it to when you're getting and setting cookies isomorphically. So read up on this utility and just make sure you make an informed decision. And then next we have display-related functionality that might be provided from UI libraries or other means. So even if these libraries are SSR friendly, the utilities might not work quite right on the server. If there's functions that rely on getting the user's viewport size or similar, on the server that's going to report as 0, So just use some caution if you're trying to work with these in setup. And then last but not least, a note about third-party scripts. Although you can load these through mechanisms like use head, if your script is not essential, it can improve your app's performance and reduce your blocking time to lazy load it using a set timeout inside of an on-mounted hook instead. There's also a fantastic package worth checking out called PartyTown, which offloads the handling of your third-party scripts to web workers and frees up your app's main thread. To help us out even further with lifecycle management, Nuxt provides an array of useful built-in composables. I'm only going to discuss one of them today, but the Nuxt official documentation has a full list of them for you to explore. Use Nuxt app is a composable that provides access to Nuxt's runtime context, no import required. You can use it to determine if the app is running in the SSR portion of the lifecycle, or if it's currently hydrating on the client, and make decisions in your template and your script setup accordingly. Is hydrating differs from process.client in that it's only going to return true while hydration is actively occurring. And then after it's completed, it will flip back to false. Process.client is going to return true from the moment hydration kicks off, and then it will stay true through all other client-side interactions, so each has their distinct use case. We've handled quite a bit in our app so far on our own, but it's good to take a step back and make sure we don't fall into pitfall number 4, developing in isolation. We wouldn't go on an expedition up a mountain without some support from fellow mountain climbers, so why try to tackle performance alone? The Nuxt team has curated a fantastic list of performance-oriented modules, which I highly recommend you browse. There's bound to be one or more that helps supercharge your app's performance. We saw a large reduction in our app's blocking time by leveraging the Nuxt delay hydration module. This module drastically improved our Google Lighthouse scores by cutting our blocking time almost in half across the board. And we would have never known about it if we hadn't looked to the community. This module provides multiple modes to control how hydration is impacted. In mount mode, which is recommended, Nuxt is delayed while it mounts, as the name implies. Plugins and some third-party scripts will still work. And as soon as a user initiates an event like a scroll, a tap, or a key press, then hydration immediately kicks off. You can configure it globally through the Nuxt config file or on a per route basis using route rules. The timeout for the delay is also customizable, and there's even a helpful debugging mode. While it needs to be used responsibly and only for a progressively enhanced app, it's quite a handy module with a lot of flexibility. When we're working with ecosystem packages and their dependencies in general, we can leverage the same patterns that we discussed previously to ensure that we can work with them effectively in our SSR app. First, we need to verify if the dependency is SSR friendly. Even if the primary dependency itself is compatible, we also must ensure all the sub-dependencies that it relies on are compatible as well to avoid an SSR error. But not all issues are loud, so make sure you check for those silent failures as well, or even instances where a dependency isn't failing outright, but it's not working as you'd expect due to missing some necessary context. And for dependencies that do fall into this category, you want to control where they initialize and run in the lifecycle using process.client, SSR context, or another applicable targeting technique. And that brings us to pitfall number 5. Missing out on key Nuxt functionality. So these next 2 Nuxt features I'm going to cover offer amazing performance benefits to the majority of applications with very little overhead. First up, we have Nuxt Image. So as of Nuxt version 3.8, Nuxt Image is auto-installed when you first use either of its components, making it easier to use than ever. You can work with dynamic images requested through an API, or even with those stored as assets in the public directory of your repo. And if your deployment leverages a CDN for public assets, then you can add a simple conditional to determine where to pull from on your local directory on dev, and then otherwise point to that CDN. And take note of the format and the loading props here. With these 2 props, you can set your app up to have top-notch image delivery. Nuxt Image is terrific for image optimization, as you can do things like automatic WebP conversion with IPX. So here's an example of a ping image that we've delivered over the network tab as WebP. And if you can see it up there, maybe that size of 96 kilobytes, it might not seem that impressive on its own, but check out the original size of this image, 1.1 megs. That is a 91% reduction in file size with a single prop. I think that's pretty incredible. Nuxt Image also provides the ability to pass in modifiers to your image provider of choice. It has support for setting up global defaults and more. It's extremely robust, it provides a great developer experience, and honestly, I wouldn't build a Nuxt app without it. So next I want to look at the Nuxt link component. This is a drop-in replacement for your regular A tag or Vue's router link. Nuxt linked pages do not call a full SSR initialization from the server by default. They route on the client side, which makes them ideal for that super snappy page-to-page navigation feel. You want to use them wherever possible to provide a key boost to the perceived performance of your app. You can specify the external prop if you do have a use case where you need it to handle like a standard A tag though, and not perform that client-side navigation. And because a fresh entry into your app is going to trigger that page's full SSR response, you need to ensure that your code will function properly on both a server-side entry and a client-side entry scenario, respectively. For your everyday routing needs, lean as far into Nuxt Link as you can. Check out the docs for a full list of all of its features and also learn how easily you can customize it to suit your app's needs. Moving forward, we arrive at pitfall number 6, neglecting the server and host. So the server and its configuration do a lot of heavy lifting for an SSR app's performance. You ignore that first S in SSR at your own peril, basically. Nuxt has you covered here with a wide array of deployment presets through Nitro. But no matter who you choose as your provider, don't underestimate the power of a good proxy. Placing Nginx in front of Node as a proxy, for example, is going to have a dramatic performance improvement over running all your web traffic through Node alone. And once you have your app deployed to its destination, research your provider thoroughly, look into their proxy and CDN configuration, or if you're going custom, set up your own. Here's where things get pretty exciting. So when you pair your proxy's server-side cache with a client-side caching strategy set up in Nuxt, performance magic happens. Let's look at how to set this up with route rules. So hybrid rendering was the feature I was the most excited about when Nuxt 3 was first announced, and route rules is the gateway to this awesome capability. SSR, SPA, pre-render, and more, you can decide what works best for your app on a per-route basis. Route rules are defined in the Nuxt config file, or you can opt into a Nuxt experimental feature called inline route rules and define them within your pages directly. Defining rules for redirects, headers, rendering strategies, and caching is straightforward and powerful. Do note that route rules as a feature is still in the experimental status with Nitro, so it may be prone to more rapid changes in iteration while it's still under development. However, as it stands today, route rules is already chock full of potential, and it can be a true asset for performance. As I mentioned earlier, you can use route rules to set up various types of client-side caching, which is already pretty great. One popular technique is SWR, which stands for Stale Will Revalidate. This is a best of both worlds strategy that combines your cached page responses with customized refresh thresholds, and it can be set up so easily with route rules. If you take this one step further and combine SWR with a server-side cache that you've set up on your proxy, then you achieve some really awesome results. Instead of relying on an individual user's visit to determine the caching behavior, you can check if anyone at all has visited your page within the specified window and broaden the performance impact of your cache. In an SSR app, caching really is king, as it cuts out the Nitro response window entirely, which could be several seconds long if you have a lot of logic and API requests happening on the server. So taking the time to plan and configure a caching layer that makes sense for your needs is worth the investment. Pitfall number 7 is treating our app's build as immutable. So you can do a lot of performance fine-tuning with the hooks that Nuxt provides. Don't be afraid to try making some adjustments through build time hooks to further improve your app's core web vitals. With the build manifest hook, you can change how script and link tags are included in the server's response. And because we're changing the manifest, there's no negative performance impact like the Nitro plugin example that I looked at earlier. We can calibrate our build by removing references to external CSS files, because in SSR apps, this CSS is automatically inlined for us in the server response. So the CSS stylings in the head are redundant, and removing them from our manifest saves us from a lot of unnecessary network calls. You can also experiment here with adjustments to prefetching and preloading behavior for linked files right in this same hook. So if your app is on the larger side, you might find that disabling these behaviors leads to improved core web vitals for first contentful paint and largest contentful paint. And while we're on the topic of CSS, let's discuss minification. Nuxt already minifies all of its chunked CSS with CSS Nano by default. However, as we just saw, SSR apps have their CSS inlined into the server's HTML response, which is a good thing. But this inline CSS is not minified out of the box. It's easy enough to change that by adjusting a bit of Vite configuration. So if you want to minify this inline CSS, set build minify to true in the Vite object inside of Nuxt config, and voila, your CSS is minified no matter how you deliver it. And so we reach our final pitfall. This one causes me a little bit of heartache. I'm giving up on SSR. I've had discussions with devs who have said, hey, I gave this SSR thing a try, but it's so complicated. I don't think it's worth the headache. I'm going to go back to an SPA. And I want to be clear, there is nothing inherently wrong with an SPA. It all depends on your use case. But if you do have a large-scale Nuxt application, hundreds or thousands of routes or more, we have a lot of dynamic, user-specific data, or performance and SEO are paramount concerns, then SSR is going to be a strong approach that I would recommend taking a look at. There are many other great use cases for it as well, but at the end of the day, it comes down to a decision that you should make based on the needs of your application. Now let's talk about when problems do strike during development. A server-side error is often going to throw this big, pretty scary-looking 500 without a lot of other clues in the dev console. But don't panic. Remember our saying one last time, the client enjoys browsing cookies in the window display. So that's a good starting point as you're looking for the cause of a server error. And if that doesn't pan out, check your code and your dependencies to see if they leverage client-specific utilities. In this example here, the $sanitize helper is being called on the server, but the package providing it is not SSR friendly, so this call needs to be deferred to the client. And as of Nuxt version 3.11, server-side errors, warnings, and console logs bubble up to the browser, which is an amazing quality of life feature that makes debugging SSR apps so much easier. Check it out. If you're running an earlier version of Nuxt, though, you can always check your IDE's terminal to see your server-generated logs there instead, though. And if you feel like you're at a complete loss despite trying to debug something, remember, we're in this together. Join the community and you will find a helping hand. I can attest. The Vue and Nuxt community is one of the best out there, truly. We were all beginners once, and we're still learning now, no matter how experienced. Nuxt has an entire page dedicated to supporting developers and guiding them to the most effective way to get help. While developing an SSR app does have more that we need to consider as developers, I believe that the benefits, especially to performance, outweigh the technical learning curve. And Nuxt is leading the industry in making this form of application development accessible to all experience levels. So don't give up. That was quite a lot of ground we've covered, and we've reached an important milestone in our trek, but the journey is far from over. As we look to the horizon, there's an ever-expanding list of awesome Nuxt features related to performance to look forward to. Server components, inline route rules, and Nuxt client fallback are currently in the experimental status and can be opted into through Nuxt config, so you can explore the performance and DX benefits of these features today. And then a bit further out, on the Nuxt roadmap, there are two first-party modules slated, Nuxt scripts and Nuxt assets, that address some of the key performance pitfalls that I discussed throughout this session. And the list goes on. There's always something new the Nuxt team is cooking up, as you heard from Daniel this morning, so be sure to keep your eyes peeled in the weeks and months ahead. Whether you're on a current journey with Nuxt 3 or you're keen to embark, I hope awareness of these pitfalls help you avoid a metaphorical avalanche and summit the mountain with this toolkit in hand. I hope this talk inspires you to go build something awesome with Nuxt 3. If you have any performance tips or tricks of your own that I didn't cover here, feel free to reach out and share them with me. And that's a wrap for me today. Thanks for your time.